going to finish off the modern physics unit talking about the standard model of particle physics. And I said before, as the energies of the particle colliders got higher and higher and higher, they could smash apart nuclei and find that nuclei were made up of protons and neutrons. It turns out that when they got at even higher energies, they found that you could split neutrons and protons. So neutrons and protons are made up of smaller particles called quarks. Okay, and this is going to sound really strange for a moment or two. Don't worry about it too much. But I'm going to say a proton is 2 up quarks. And a down quark a neutron is 1 up quark and 2 down quarks. Okay. Now, this sounds like a foreign language. Quarks, ups and downs, and so on. Okay, but you don't have to memorize it. They're on the reference tables. Okay, and it gives you the charge for each one. So this right here, that charge is on the reference table. So you don't have to memorize what the names of different types of quarks are. There's an up quark, a down quark, charm, top, string. Those are the different quarks. Now, all matter can be classified as what's called a hadron or a lepton. Again, foreign language, but you have to memorize it. The leptons are these down here, and they never combine with anything else. Okay, so an electron you're always going to find by itself. Okay, and there's 6 different types of leptons. Quarks always combine. Okay, hadrons are made up of different combinations of quarks. Baryons are hadrons which are made up of 3 quarks. Mesons are a type of hadron which are made up of a quark and an antiquark. Luckily, you don't have to memorize that either. It is on the reference table. So your next reference table looks like this. Okay, all matter could be classified as hadrons or leptons. Okay, leptons never combine with anything else. They're just single particles. Remember, you can look those up on the other chart. And hadrons can be split into 2 classifications, baryons or mesons. And then baryons are always made of 3 quarks. Mesons are made up of a quark and an antiquark. Okay, I'm going to go here. Antiquark. An antiparticle has the opposite mass of its associated particle. Otherwise, it's identical to the particle. So, these terms, baryons and mesons, they're not the name of the particle, they're a classification. So it's like saying mammals or reptiles. They're never going to ask you for the name of a particle, but they are going to ask you for the classification. So here's an example problem. What's the charge on an up quark, and what is the charge on an anti-electron? So if I go back to the previous page, the charge on an up quark is right here, plus 2/3. So I can say that it is plus 2/3 of the charge on an electron. Now that's a little weird because we said these always have to be whole numbers of charge of an electron, but that's not true of quarks. So when quarks combine, the combination will always be a whole number. And the second part was the charge on an anti-electron, and electron is minus 1. So we'll make a note of that. An electron is minus 1. So then an anti-electron, for an anti, you put a line over the top of it, and that's going to be plus 1 for the charge. Now, the particle is made of an up quark, a down quark, and a top quark. What type of particle is it? So for part A, again, I'm not asking for the name, okay? I'm just asking for its classification. So it's made up of 1, 2, 3 quarks, up and down to the top. It's made up of 3 quarks. I call it a baryon. B, what is this charge? You just look up all the different parts, the up, the down, and the top. So if I go back to this table, okay, the up is 2/3, the down is minus 1/3, and the top is plus 2/3. So it's 2/3 minus 1/3 and another 2/3. If I add those up, I have a positive 4/3 minus 1/3. Altogether, this gives me a charge of plus 3/3, which is 1. So you'll always end up with a whole number when you combine three quarks. So here's another one. Danielle becomes an experimental physicist, discovers a new particle she names a Lynch, and she determines it's made of a top quark and an anti-bottom quark. Part A, what type of particle is it? I will go back here. It's made of a quark and an anti-quark. That's true. I call it meson. So the name of the particle was a Lynch. She named it that, but its classification is a meson. And B, what is its charge? So it's made of a top quark and an anti-bottom. For anti, put a line over it, so it's going to be a top, an anti-bottom. If I go back to the chart, right here, I look at it, the top is 2/3, the bottom is minus 1/3, so an anti-bottom would have the opposite charge, it'd be plus 2/3. So, I just said this is plus 2/3, and anti-bottom is plus 1/3. If I add those together, I get 3/3, which is plus 1. So, all the words are confusing. You have top quarks, bottom quarks, term quarks, upchart, meson, baryons, all these weird words, but it's really easy if you know how to use those tables. Now, for the next page, we're going to finish this off. Antimatter, okay, is the same as matter, but with the opposite charge. That's one thing. Okay, if matter and antimatter touch, they annihilate each other. To annihilate means to explode and all of the mass is gone. It turns into energy. Okay, so now, how much energy is created if a proton and antiproton touch and annihilate each other? So my proton, okay, has a mass of 1U or 1.67 times 10 to the minus 27 kilograms. The antiproton has the same mass. It's identical except for the charge. So if they annihilate each other, the mass destroyed, 2 U's. Or if I want it in kilograms, I just add or double the 1.67 times 10 to the minus 27, and I get 3.34 times 10 to the minus 27 kilograms. Now, if I want to find out how much energy that turns into, I can do it two ways. Okay, I can do the energy is 2 U's. Remember, if the energy is in atomic mass units, you just multiply it by 931 eVs per U, and you end up with 1862 eVs. Okay, if I use kilograms, I'm going to do E equals mc squared. So that's 1.67, I'm sorry, it's twice that, 3.34 times 10 to the minus 27 kilograms times 3 times 10 to the 8 meters per second squared. And if I do that out, we'll get that the energy destroyed, or the energy created, is 3.006 times 10 to the minus 10. So there are a couple things that you need to memorize. Okay, protons are made up of two quarks, two up quarks and one down quark. So a proton is equal to UUD. You have to know that because they're going to ask you questions on it. Neutrons are one up and two down, so you can memorize that. An antiproton is called an antiproton. An antineutron is called an antineutron. But an antielectron had its own name. Okay, they call it a positron. Okay, it's a positive electron. And then neutrinos. The word neutrino kind of means baby neutrons. Okay, they were discovered by Enrico Fermi, who was Italian. So the ino on the end of the word means little. So they're like a neutron. They don't have any charge, but they have very little mass. And when quarks combine, the charge must be an integer.